So what we have here is an example of a differential in a car that I've made, and it's rendered in Meccano, which is an old assembly kit which has the name of erector sets in America. And what I have here is, I think, better seen upside down. So I'm going to turn this upside down and put it on a crate so we can see the inner workings of this a little better. And what we have here is what they call a cage, which has 4 gears in it, one of which is redundant. This is what's called a pinion gear, and it meshes against a contrate at right angles to itself, and it faces another pinion. But if you remove one of these pinions, it'll work just as well. It's just there to keep everything aligned and in balance. These are all freewheeling along this axis, so they're mounted loosely on this this rod here. So you see, if I turn this rod, the gears don't turn, which means they're just freewheeling on this rod. Now, these contrates are, however, attached to the wheels on the outside, so they are eventually being driven, but not directly by this wheel, because as you can see, if I turn this thing, which is the drive shaft, this drive shaft itself has a pinion gear meshing against the face of a contrate gear. As you drive this whole assembly is moving as a unit, and none of the gears in there seem to be turning at all, because there's equal resistance, in this case none, on both wheels. So as I turn this, like in a more normal forward or backwards motion, none of the internal gears are turning at all. Look how stationary they are. But if you attempt to stop or slow down one of them, then these gears will start turning, as I'll soon demonstrate. The rest of the chassis is pretty straightforward. It has a steering column with a parallelogram kind of a steering mechanism, and you have a gearbox which has 2 gears, first gear and a second gear, and a neutral in between. And here's the shift rod, which moves the gears into meshing against the lower gear and higher gear. And here's the stick shift up front. And the whole thing is driven by an AC motor that is driven by this transformer, which is a model train transformer, a line L train transformer, which I happen to pick up for about 30 bucks or so on eBay. Okay, so let's just turn this on to see how this works. Oops, I forgot to turn the motor on. Okay, let's. So now you can see that the whole cage is moving along with the wheels, and it's right now in second gear. I'm going to move it to first gear. And you can see there's a little clutch here, which allows the thing to be engaged as you slide this plate forwards and backwards. But the gears mesh against either the bigger gear or the smaller gear here. And this is driving this pinion gear here, which in turn drives the contrate gear here. You can see there's quite a bit of a wheel shimmer here, because these are just regular Meccano parts and they're not aligned 100%. So allowance has to be made for the wobbliness of it, and that's what some of this extra stuff on the ends are. But basically the differential is just this part here. Now notice how if I stop this wheel here, the other wheels actually move still, but at a speed almost twice as high, exactly twice as high as the drive shaft angular speed. If I release it, everything goes back to normal. Likewise, if I stop the other wheel, it's this wheel that's taken up the spinning. So anyway, that's how the differential works. And the reason why I'm driving it with the AC motor right now is that I don't have anything better until I get something that can be run off a DC battery motor. So that's coming up next.